In this part of 1.6, we're going to use U substitution to solve equations that are quadratic in form. An equation that is said to be quadratic in form can be written as AU squared plus BU plus C. So in our examples, we're going to have something other than U in there that's a little complicated. Maybe it won't be just an x squared. Maybe it'll be x to the fourth or x plus 2 or something. We're going to substitute U in, solve the equation like we would a quadratic, and then plug back in what U is equal to. In our first example here, we're going to solve this equation. The first thing I need to do is figure out what I'm going to set U equal to. I always just want to set it equal to whatever this middle term is, because I want it to be U squared plus or minus something with U and then minus 2. So whatever this middle term here is what I'm going to set U equal to. So let U equal x plus 1 to the 1/3. Now you'll notice my exponent on the first term, the x plus 1 to the 2/3, is 2/3 here. Well, once I replace this with U, it's just going to be U squared. So that's where we keep that 2 there. I replaced my middle term with U, so I have minus U. You could put minus 1U if you want. And now we're just going to factor like normal. What multiplies to -2 and adds to -1. Factor by grouping. And now we're ready to take what U is equal to and plug it back in. So let's take what U equals and plug it in for each of our U's. Okay, so now what we need to do, since we're solving, is we're going to set each of these factors equal to 0 in order to solve. So one at a time here. Move the 1 over by subtracting. And now we need to get rid of our exponent of 1/3. The way that we get rid of exponents is we raise it to the inverse. The inverse of 1/3, if you flip 1/3, you get 3/1 or just 3. So I'm going to raise each side to the 3rd power. That cancels out my exponents because they multiply to 1. And then I have an easier equation to solve. And now for the other factor, we're going to set it equal to 0. Move the 2 over by adding it. And then again, we're going to need to get rid of this exponent, so we're going to raise each side to the 3rd power. And we get x equals 7. So our answers for this problem are 7 and -2. You can always check your answers by plugging them back in. So we could take 7, plug it into the original problem everywhere that we see an x, and see if we get a true statement. And then do the same thing with -2. On example B, we're going to let U again equal our middle term. So we have U equal to x to the -1. If we replace U, we get 6U squared plus U equals 2. We need to move that 2 over before we can factor so that everything's on the same side. And now we're going to factor. What multiplies to -12 and adds to 1? I'm factoring by grouping here. So pull out a GCF from the first 2 and then from the last 2. And then I have my factored form. I'm going to start with setting the left one equal to 0 and solving. Move your 2 over, and then divide by 3 to get x alone. And now again, we're trying to get rid of this exponent on x. So we're going to raise it to a power that when you multiply those two exponents, you just get a +1. So in this case, we're going to raise it to the -1. That gives me just x on the left. And on the right, whenever we raise a fraction to a negative exponent, all it does is flip the fraction. So it moves the 3 to the top and the 2 to the bottom, and it's still negative. Same thing with our other factor. For this example, again, we're looking at our middle term to see what to set u equal to, and in this case it's going to be just x squared. So let u equal x squared. So now our equation looks like 12u squared minus 11u plus 2, and we can go ahead and factor that by grouping. Okay, I am going to plug x squared in for u and then set these equal to 0 and solve. Another thing you could do is you could set 3u minus 2 equal to 0 and solve, set 4u minus 1 equal to 0 and solve, and then plug in x squared for u and solve further. So a couple ways to do it. I just like to plug in x squared at this point. So I'm going to move my 2 over by adding, and then divide by the 3. And now I need to get rid of that squared. So I'm going to take the square root of both sides, which will give me just x on the left side. But don't forget, anytime you take a square root in an equation, if you put the square root in, then we're going to need to have a plus minus in front of our answers. We're left with a radical in the denominator, so I'm going to write these both in their own radical, 2 and 3. So we need to rationalize. So our first answer so far is plus minus square root 6 over 3. Now for our other factor, plug x squared in for u. Move your 1 over by adding. Divide over your 4. And then again, we're taking the square root of both sides. This time, 1 and 4 are both perfect squares, so we actually end up with an answer that doesn't have a radical in it. So we get our final answers as x equals plus minus 1/2 and plus minus square root 6 over 3.